I sent or I called, I think it's probably your mom's phone, and left a message. If this video helps, just ignore that message, or if it doesn't help, then you can give me a call, when she tells you about it, and, I'll help you try to figure this out to make sure you understand it. With scale factor, all I'm gonna explain on these first ones is just with the scale factor, all you're doing is you're taking two sides that match up in the two triangles and setting up a ratio. So if I look at this first one, if I wanted, and I'll name the triangles first in each one, just so I have that information there. If I name the first triangle RLG, when we look at it, we know that this 67 matches up to that 67. When I add these up, this angle is going to end up being 34 degrees, and this angle is going to end up being 79 degrees. So this 79 matches up to that 79, and then this 34 matches up to this 34. So when we name them, that's how they have to match up. So R matches up to N, the L matches up to the C, and the G matches up to the P. So that's the way that they have to be named to match them up. But as far as the scale factor goes, then what you do is just pick two sides that match up. So if I look at the names right here, I got segment RL. Well, segment RL I know is 30. And then segment NC is what it matches up to over here in the names. Well, segment NC is 45. And you're not going to set up a whole proportion, you're just setting up one ratio. And if we reduce that down, 15 will go into 30 twice, 15 will go into 45 3 times. That's the scale factor. And what you can do with the scale factor, and what might make this week's assignments a little easier, is you can use that scale factor when you go to set up your proportion as one of your ratios, so that, you know, maybe you got X up here and some other number down here, so that it makes it easier to do the multiplication when you cross multiply. If you don't like scale factor, then you could, you could leave it 30 over 45 and use that in your proportion. It just makes the multiplying harder and the dividing harder. It makes you come out with bigger numbers. Next one, if I look at this next one, I'm going to try to match these up without actually naming them this time to find the scale factor. If I look here, this side is between the two, so these two sides match up. And this one has, the 15 has this on the end, so it matches up with that over there. The 20 down here has this on one end, it matches up with the 12 over here. So when I set up my ratio to find my scale factor, it's 20 over 12, and then you just reduce that down. 4 will go into 20 5 times, 4 will go into 12 3 times. So the scale factor would be 5/3. The other thing that I said about scale factor is because I didn't really tell you here which way to go. This scale factor would tell us 5 to 3, since the top number is bigger than the bottom number, that we're getting bigger, or it's an enlargement. And since I didn't really tell you which way to go, we could have just as easily went the other direction and went 12 compared to 20, which would make the scale factor 3 to 5, and if the top number of the scale factor is smaller than the bottom number, then it's a reduction. So since I didn't tell you which way to go, I would accept either one of these two answers, either 5/3 or 3/5. Number 3, just matching them up, you can see that the 5's between the 1 mark and the 2 mark. The 15's between the 1 and the 2, so that means they're going to match up. So 5 over 15, and if you reduce it down, 5 will go into 5 once, 5 will go into 15 3 times, so your scale factor is 1/3. bottom, if I found this other angle, it's gonna be 48 degrees, and if I found this angle, it's gonna be 42 degrees. And when you look at these, the 10 here is between the 48 and the 90. The 5 over here is between the 48 and 90, so those two sides match up. So 10 is gonna match up to 5, so you could put 10 over 5, or again, you could go the other direction, put 5 over 10. Doesn't matter to me which way you did it. All that's gonna happen is this scale factor is gonna be 2 to 1, and this scale factor is gonna be 1 to 2. And all that's saying, anytime you're dealing with the scale factor, it's saying for every 2, whatever the units are in these two triangles, so maybe it's meters, for every 2 meters in this triangle. So if I'm walking down through here and I walk 2 meters, that would be the same as going over here to this triangle and walking 1 meter. So for every 2 meters in this big triangle, there's 1 meter in the small triangle. And if we set it the other way around, it'd be for every 1 meter in the small triangle, there's 2 meters in the big triangle. So our scale factor here, 2 to 1, and again, it could be 1 to 2, either one of those, whichever one, because I didn't really say if it was an enlargement or a reduction. If I'd said it's an enlargement, then it has to be this one. If I'd said it's a reduction, then it has to be that one. Hopefully that helps. Let me know, please. And if you have any other questions, feel free. You can still call me if